Let's look at the electromagnetic spectrum. So electromagnetic waves are formed when an electric field couples with a magnetic field. And these two fields are perpendicular, two waves are perpendicular to each other. This is really what light is, as well as microwaves or radio waves. So what forms an electromagnetic wave? Well, I want you to think about a vibrating electric charge, so an electron. Light behaves like a particle, but it also behaves like a wave. And we call this wave-particle duality. A man named Albert Michelson measured the speed of light. And the way he did it, basically, is he took an octagonal mirror, so all of this is mirrors, and he knew its speed of rotation, so you can see it's rotating to the right, clockwise, and then notice how far away this concave mirror is. And when he rotated this mirror at the proper speed, this beam of light that came from right here would hit the side of the mirror, reflect off, hit the concave mirror, and then come all the way back, and he could detect it here. So his eyeball is right here looking in. So the light would travel from its source, hit the mirror, reflect off the side of the rotating mirror, hit the curved mirror. This is another flat mirror to turn it to the curved mirror, and then it went all the way back, and then he could see it here. By knowing the speed of rotation and the distance to the curved mirror, he was able to calculate the speed of light. Now, for us, we're going to round it to 3.0 times 10 to the 8th meters per second. Now, some other things you need to know about waves. Our wave equation uses c equals lambda times f. And what this means, c represents the speed of light. It comes from the Latin word celer, which means fast. Think of the word accelerate, so it has the word fast in it. So speed of light is c. Wavelength is this letter right here, and we call that lambda. And it's just a Greek letter that we use for a variable. This guy just represents frequency, so it's just an italics F. So wavelength, I'm going to show you different ways we can measure wavelength. That's always in centimeters or meters or nanometers. Frequency is how many waves go by you. So wavelength is a length, and we can measure it from the top of this crest to the top of this crest. So we could also say here lambda. So it's kind of a tilted T. You could also measure wavelength from the beginning of the crest to the end of this bottom part. It would be exactly the same length, lambda. This part is called a trough. T-R-O-U-G-H. Any two consecutive points on a wave will give you the wavelength. So one other example, we could measure from the beginning of the trough to the end of this crest, and that would be the same length, lambda. Frequency is how many cycles or wavelengths pass you per second. All right? The units are a little different, but you've probably seen them before. They're called hertz, and that's in honor of a scientist, and it means per second, so 1 over seconds. Right? So another way to write this is we don't write anything for cycle, we just write seconds, 1 over seconds. Okay? So here we have one with a high frequency, so you'd have a bigger number than a lower frequency wave. Now, one of the things I would like you to remember are the 7 different parts of the electromagnetic spectrum. And I have a mnemonic or a saying that will help you remember these. But the 7 different parts are radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. So my mnemonic is the same. Run, Matt. In victory, you excel greatly. So run is for radio. M is for microwaves. I is for infrared. We'll talk about each of these in just a minute. V is for visible. U is for ultraviolet. X, X-rays. And G, gamma rays. And this is after one of our alumni who skied for Boulder. You can see the buff logo on his uniform, and he was one of their top athletes. So all of these waves are emitted by the sun. Some get through our atmosphere, and some are blocked by our atmosphere or different parts of the earth. So let's talk about radio waves. Radio waves are just like you think, but they're the longest wavelength in the electromagnetic spectrum. They range from about 3 kilometers, even longer than that, to about 30 centimeters, which is about 12 inches. The frequency goes from 100 kilohertz, kilo is 10 to the third, so 1,000, and gigahertz is 10 to the ninth, a billion hertz. This accounts for AM waves, FM waves, TV, your cell phone, as well as cordless phone. AM waves stand for amplitude modulation. So when a radio station is a certain AM, they have a bunch of waves that are within their given frequency. For frequency modulation, you have waves that are on top of that. So you the radio station, say 101.5 FM, that frequency has a carrier wave associated with it. Not the best visuals for you. Your TV is just a longer wave, and then cell phones can be either radio waves, sometimes they're the next one down, microwaves. Again, they're the longest of all of them. All your FM waves are around 3 meters in length. Microwaves. We use microwaves for our cell phones, for Doppler radar. Their wavelength is from 30 centimeters to 3 millimeters. So kind of think about that. That's real small. Those are the smallest increments on your ruler. 300 megahertz. Mega is 10 to the 6th, a million, to 300 gigahertz, 10 to the ninth. Microwave ovens is one use for microwaves. Cell phones. Doppler radar is our last use. And I'll show you how microwaves excite the water molecules in your food, and that's how it heats it up. I'll show you that in class tomorrow. Infrared. Infrared waves, we know it as heat, but it's also used in your remote controls. The wavelength is 3 micrometers. This stands for 10 to the minus 6. The word I just said was micrometer. Micrometer. Its frequency, 300 gigahertz, 10 to the ninth, to terahertz, 10 to the 12th. So we're getting higher and higher in our frequencies. We know it as heat, and it's used for remote controls. So we can't see it, but your camera can pick it up as a flash or, say, a video camera. The next one is the light you know. It's visible light. And I'd like you to know the colors, Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. So indigo, indigo. The wavelengths run from about 700 nanometers to 400 nanometers. A nanometer is a billionth, 10 to the minus 9. The frequency is 750 to 400 terahertz. So 10 to the 12th hertz. A lot of times you'll see it as 7.50 times 10 to the 14th hertz. And they don't use a prefix. And it goes all the way to 4.00 times 10 to the 14th hertz. It's Hz. So red has the longest wavelength. with violet having the shortest wavelength. So a lot of times we can do this little tiny lambda, and red would be a really big lambda, but the frequency of red light is little tiny thing. Frequency of violet light is really big because they both travel at the speed of light. So wavelength is inversely proportional to frequency. Ultraviolet light is the light that is from 400 nanometers to 10 nanometers, and again, a nano is 10 to the minus ninth, and its frequency is 7.5 times 10 to the 14th to 3 times 10 to the 16th hertz, and it causes sunburns as well as cataracts in the eye. And the cataract is when your lens in your eye gets cloudy. And they have an operation where they can take that out and put in a new plastic lens for you. We also use sunglasses to prevent the UV light from coming through. So when you buy sunglasses, you should look for UVA and UVB protection. And that means it absorbs that light and it doesn't get through to your eyes, so you won't get cataracts. We also use UV light to detect objects in space. So you can see this is in UV light, this is invisible light, the red stuff. So you can see more details with the UV light. So I know this by looking right here for UV, and here that means visible light. So they're the same objects, but in different spectrums. X-rays, you know, can look at your bones or your teeth. The wavelength is less than 10 nanometers, and the frequency is greater than 3 times 10 to the 16th hertz. For gamma rays, those are the shortest, they're less than 1 picometer for their wavelength. Picometer is 10 to the negative 12th, and their frequency is 10 to the 20th and higher hertz. Gamma rays our Earth protects us from gamma rays. They don't get through our atmosphere. For UV rays, way back here, the ozone protects us from UV rays, so we don't get too much UV coming through our atmosphere. So I want you to remember all 7 parts, so I think it's easiest to remember my saying, run, Matt, in victory, you excel greatly. And that goes from a large wavelength, small frequency, to a small wavelength, big frequency, and all of these travel at the speed of light. So knowing that, we can do a little bit of math. So your first equation is C equals lambda times F. And the wording is if an electromagnetic wave has a frequency of 6.67 times 10 to the 14th, what is its wavelength? So electromagnetic wave, you know that C is equal to 3 times 10 to the 8th meters per second. Frequency is the one that ends in hertz. It's a big number, so you're always going to have a power of 10 to work with, 10 to the 14th hertz. Remember, a hertz is a per second, and we want to know the wavelength. So we're going to end up with meters for our units. So to rearrange this equation, I'm going to take C equals lambda times F, and I'm going to divide both sides by F. So you end up with lambda equals C divided by F. So C is 3 times 10 to the 8th meters per second, and you're going to divide it by 6.67 times 10 to the 14th hertz. So on your calculator, you can practice this tomorrow in class, you're going to use an exponent key. So it usually says EE or EXP. So on my calculator, I type in 3 and then my exponent key. The calculator knows that times 10 is in there, so I'm just going to write 8 divided by 6.67 exponent 14. When you divide properly, you're going to get a very small number. I'm going to round to 3 numbers, or 2 decimal places, 4.5. Look at the very end of your number. It's 10 to the minus 7th, and you're left with meters. This hertz is 1 over seconds, so seconds cancel. And that's our wavelength. So we're going to practice finding wavelengths and frequency tomorrow in class. That's it.